In this video, we're going to continue our discussion of power series functions. Given f of x is equal to 2x plus 4 divided by x minus 1 times 2x plus 1, express the function as a sum of a power series by applying partial fraction decomposition. Also find the interval of convergence and the radius of convergence as well. Let's start by writing this fraction as a sum of two different fractions. So we have 2x plus 4 divided by x minus 1 times 2x plus 1. In the denominator, we have a product of two linear factors, so we write this as a divided by x minus 1 plus b divided by 2x plus 1. Take common denominator. The common denominator is x minus 1 times 2x plus 1. Now x minus 1 goes into the denominator 2x plus 1 times, so we get a times 2x plus 1 plus b times x minus 1. Now we need to clear out the denominator, so let's multiply both sides by x minus 1 times 2x plus 1. So on the left-hand side, we're going to get 2x plus 4. On the right-hand side, we're going to get a times 2x plus 1 plus b times x minus 1. Now we have to solve for a and b. So what we have is 2x plus 4 is equal to a times 2x plus 1 plus b times x minus 1. Let's plug in x equals 1 into both sides of this equation. So we get 2 plus 4, that's 6. Into the left-hand side is 6. The right-hand side, we get a times x equals 1. Plug it in here, we get 2 plus 1, that's 3. Plus b times 1 minus 1, which is 0. Now we can solve for a. So we get 6 is equal to 3a. Divide by 3 both sides, and we get a equals 2. Now, what value of x should we plug in to solve for b? Let's plug in x equals negative 1/2 into both sides. We get 2 times negative 1/2 plus 4, that's the left-hand side. And we get a times, 2 times negative 1/2 is negative 1 plus 1, we get a times 0. Plus b times negative 1/2. Negative 1/2 minus 1, that's negative 3/2. So we get 4 minus 1, that's 3, that's the left-hand side, is equal to minus 3b divided by 2. Solving for b, we get b is equal to 3 times negative 2/3. The 3's cancel out, and b is equal to minus 2. So we have written this fraction 2x plus 4 divided by x minus 1 times 2x plus 1. We applied partial fraction decomposition, and we write this as a divided by x minus 1 plus b divided by 2x plus 1. And we found a to be 2, so 2 divided by x minus 1 plus b, which is negative 2, divided by 2x plus 1. Now, you can see that each of these, we can tweak it and make it look like a geometric sum. So our goal is to make every fraction fit this pattern of 1 over 1 minus x is equal to summation n equals 0 to infinity x to the power of n. The interval convergence for this geometric series is absolute value of x less than 1. Radius is equal to 1. So let's look at the first fraction, 2 over x minus 1. How can we make it fit the pattern of a geometric sum? So I'm going to factor out minus 1 from the denominator. We get negative 1 times 1 minus x. And we can write this as negative 2 times 1 over 1 minus x. And now we have the sum of a geometric series. So we get minus 2 summation times summation n equals 0 to infinity x to the power of n. All right, so we have written the first fraction, 2 divided by x minus 1, as minus 2 times 1 over 1 minus x. This is equal to minus 2 times summation n equals 0 to infinity x to the power of n. This is a geometric series that converges for absolute value of x less than 1. The interval of convergence is x between 1 and -1. That's the interval of convergence. And the radius is 1. Radius of convergence is 1. So now let's look at the second fraction. The second fraction is -2 divided by 2x plus 1. We want to fit this into the pattern of a geometric sum. So we write this as -2 times 1 over 1 minus 2x. And now we have the common ratio. This is r equals -2x. So we can write this as -2 times summation n equals 0 to infinity minus 2x to the power of n. So the second fraction is also the sum of a geometric series. So -2 divided by 2x plus 1, this is equal to -2 times summation n equals 0 to infinity minus 2x to the power of n. We get -2 times summation n equals 0 to infinity minus 2 to the power of n times x to the power of n. Let's multiply this -2 inside the summation, and we get summation n equals 0 to infinity minus 2 to the power of n plus 1 x to the power of n. So just to summarize, we've written this fraction, -2 divided by 2x plus 1, as a geometric series. This is a sum of a geometric series, and the power series representation of this geometric sum is n equals 0 to infinity minus 2 to the power of n plus 1 times x to the power of n. All right, so let's review that. We have -2 divided by 2x plus 1. And we wrote this as -2 times 1 divided by 1 minus 2x. And this is a sum of a geometric series where the common ratio r is equal to -2x. And the power series representation of this is n equals 0 to infinity minus 2 to the power of n plus 1 times x to the power of n. Now this is a geometric series. So this is geometric series with a common ratio r equals -2x. It converges when the common ratio of r, absolute value of r, is less than 1. Absolute value of -2x is less than 1. Absolute value gets rid of the minus sign, so we get absolute value of 2x is less than 1. Divide by 2, we get absolute value of x less than 1/2. So the interval of convergence for -2 divided by 2x plus 1, the interval of convergence of this power series, n equals 0 to infinity, minus 2 to the power of n plus 1, x to the power of n. The interval of convergence is -1/2, comma 1/2. These are the values of x for which the power series converges. And the radius of convergence, radius is equal to 1/2. And this is the interval of convergence. All right, since we're adding these two fractions, we have to take the minimum of the two values of the radius. So r is going to be the minimum of 1/2 and 1. And this is equal to 1/2. All right, let's put it all together. So 2x plus 4, this is the question that we had in the beginning. We were given this fraction, and we applied partial fraction decomposition, and we wrote it as a sum of two geometric series. X minus 1 times 2x plus 1. This is equal to 2 divided by x minus 1 minus 2 divided by 2x plus 1. And we found the power series representation for each geometric sum. We get -2 times summation n equals 0 to infinity x to the power of n plus summation n equals 0 to infinity minus 2 to the power of n plus 1 x to the power of n. So just to summarize, we have 2x plus 4 divided by x minus 1 times 2x plus 1. We found the power series representation of this function as summation n equals 0 to infinity minus 2 plus minus 2 to the power of n plus 1 times x to the power of n. Notice we're grouping these two summations because we can just factor out x to the power of n and put all the coefficients, group them together, and have one summation. Now, the radius of convergence is the minimum of the two of these because the first one, this one, had a radius of 1, radius of convergence. The second fraction had a radius of convergence of 1/2. But because we're adding or subtracting these two series, we have to take the minimum of the two radius of convergence. So that's why we take radius is equal to 1/2. That's the radius of convergence that works for both of them. And the interval of convergence is x is larger than negative 1/2, less than 1/2. That's the interval of convergence. And if we write this in summation form, in expanded form, we can plug in n equals 0, n equals 1, n equals 2. This one would be n equals 0. If you plug in n equals 0 into this summation, you'll get this first term, minus 4, because we get minus 2 to the power of 0 plus 1. That's minus 2 is minus 4 times x to the power of 0. X to the power of 0 is 1. N equals 1 gives us the second term, which is 2x. N equals 2, the third term. N equals 4 gives us the fourth term. All right, thanks.